I joined the university 22 years ago, and one of the things that they do not tell you, and I never expected, was to see your former undergraduates, and in this case postgraduates, flourish in their careers. So Garnet, Dr. Garnet Ridgway, I apologise, and I had a very small part in the doctor bit, is the head of flight dynamics and head of flight test at Britten-Norman, the manufacturer of the iconic Islander series aircraft, the sales team said. He has a PhD from the University of Liverpool and has previously worked for Airbus, MBDA and QinetiQ. He's also a graduate of the Empire Test Pilot School, so slightly underqualified. So it's, without further ado, could we welcome in the usual manner Dr. Garnet Ridgway.
Good evening, and thank you for all coming. It's great to see so many people here, and honestly quite a strange experience that my boss, his boss, the investor of the company, also my mother are all in the room. So we will aim to pitch the technical content somewhere in between those stages. Rugged, reliable, and relevant. Enough about me. Let's move on to the aircraft. I just thought I'd get that out of the way nice and early. So it was my pleasure to talk to you today about flight testing this fantastic aircraft that we see in the photo here, and a little bit about Britten-Norman as well as part of the process. So specifically Britten-Norman in 2025, because it's a company with a rich history, and I've only been within that company for the last 5 odd years. There are probably people in the room that know a heck of a lot more about that history than I do, and I'll be fascinated to hear some of your stories at some point. But today's lecture, the bit I'm more qualified to talk about, is Britten-Norman today. An overview of the project that was associated with this flight test program, the program itself, and then a brief whiz through the certification process, just because it is, in some ways, quite interesting, but it is important as well as being interesting. And a tiny bit on the future of the company beyond 2025 and our plans, which are really quite exciting. Okay, so before I jump straight into me, about myself, I'd mention that some other key players in the project that I'm presenting today. So Graham Tomlinson, GT's in the room. He was the chief test pilot and did all the flying on this project, which is a pleasure to sit next to him, and he's a very vast experienced chap. We also have Mark Shipp in the room as technical director, who was technical lead and technical oversight of the program, and many, many others within BN. So it's not all about me this evening. However, here I am. At the bottom right there, that was my early aviation experience. So some of my earliest memories are flying to Bembridge in the back of light aircraft. And apparently sitting in the back eating crisps and arguing with the pilots. That doesn't happen anymore at all. That's days that are in the past. So yes, elsewhere in my career, as Mike said in the intro, I was at MBDA doing some single-use UAV stuff there, which was quite interesting. I then moved to QinetiQ. And I worked on helicopters, all in the flight test sort of regime. I then had the opportunity to go to the Empire Test Pilot School as a flight test engineer, specialising in advanced systems test and evaluation. So as part of that, we flew the PC-21 aircraft in the bottom, which, having come from the helicopter world, the small helicopter world, suddenly getting into something that felt like an absolute rocket ship to me was really a fun new experience, including the G-suit, the cool helmets, everything else. So really quite a breadth of experience. Then onto the Islander. It's obviously not a thrill-a-minute adrenaline type aircraft, but it has other qualities. It's not a frivolous aircraft. It's the lifeblood of many communities all around the world. It's a practical tool that gets used in the field, and I'm really proud to be part of that. So that's my background, and I'll talk to anybody who wants to know more about that at some other point. But so Britten-Norman. So do you know Britten-Norman? Well, we've been around since 1954 in various guises. Was founded by Messrs. Britten and Norman, and I think, not spotted him this evening, but we do actually have a Norman, Ash Norman, in the company. He sat there he is, I'm embarrassing him. So the family name is still involved in the company, and we're proud of that fact. The total number of aircraft we believe to be that, so far over 1,000 aircraft, which compares favourably with some very popular, famous, larger aircraft, Airbus family aircraft. Some of them are of that order of magnitude numbers as well. So a real British success story. We're currently at 110 employees in skilled roles, but the company is also expanding as well, so that number will go up very shortly. Unusually for British industry, we build things in the UK and export them to the world. So 97% historically of all aircraft that we've built have been exported. And I've got some more on that in a sec. And annual turnover of about 20 million US, which puts us very firmly in small, medium enterprise, SME territory. I won't go into huge detail of all of these things, but just to show you that for that quite small number of people I mentioned on the previous slide, we do a heck of a lot. So we are a CAA Part 21J design organisation. So we are the type certificate holder of the aircraft. So we maintain and sustain that, as well as working on product improvements, R&D, and specialised mission projects, which is the flavour of what I'm going to talk about shortly. We build stuff too. So our facility at Bembridge on the Isle of Wight is the spiritual home of Britten-Norman and is still a modern functioning production facility where production is ramping up currently. So I've got some pictures later on of aircraft on the production line in Bembridge. So that is really quite exciting and very unusual actually for, from my point of view as a graduate of an aerospace engineering program, actually having worked on large US-based projects such as Chinook or larger multinational programs, Merlin, suddenly moving to a world where all the bits of metal go into that building in Bembridge and aeroplanes come out the other end. Absolutely fantastic and really unusual in 2025. We're also a maintenance, repair and overhaul organisation, the MRO, which is Part 145 for those who are interested in OFA. So sort of another main business line aside from building new aircraft is refurbishing old aircraft that are sourced worldwide. Now obviously lots of people will claim to refurbish an aircraft for you, but when Britten-Norman does it, we really do it. So these aircraft are stripped down, nuts and bolts out, and really rebuilt from the ground up, and they come out looking like brand new, even for a really very old aircraft. And finally, we provide what would be called wraparound services, aviation services, so training, continuing airworthiness management, and other services as well. In terms of the worldwide footprint, these are the ones we know about. And there are obviously others operating in other parts of the world that we don't know about, but some stats there. We've got track of 417 islanders still operating daily, spread across 195 operators. So, I mean, that tells you quite a lot about the typical operators that we have. They're very lean organizations. They don't have huge fleets on standby, which is a fascinating world to inhabit. So the aircraft itself, so some key features here. It's quite often likened to a flying Land Rover, but we are talking a Series 1 Land Rover in some respects, rather than a nice modern Discovery. But those features are really why it's endured so well. So it's very simple to construct and maintain in the field. And when we compare to our modern, for example, Italian competitors, I ask people to look at the undercarriage. And you'll see as we do some actual photos later in the presentation, the undercarriage on the Islander does not mess about. It is two huge great tyres on a huge great tube that's bolted into the wing spar in a straight line. If you look at competitor aircraft, nice sleek Italian design, nice sleek Italian wheel, try landing that on a ploughed field or a beach with a little bit of a crosswind component. So that sort of design philosophy is repeated throughout the construction of the aircraft, and that's why people love them and operate them to this day. Some additional flavours, and I won't dwell too long on this, but fundamentally there are two Islander airframes, and these are all the current production models. There are history lessons to be had about all the hundreds of different permutations over the past 50-odd years. But we have the smaller Islander airframe, which comes in two flavours of Lycoming piston engine and a Rolls-Royce turbine engine, and then the larger, the BN2T-4S aircraft, which has a stretch fuselage, larger wing, much heavier, much more capable, larger turbine engines. I say larger, when you look at these engines removed from the aircraft, fascinating bit of kit. It's about this size, and it produces 400 horsepower absolutely incredible. It's first time I saw one, I thought it was a scale model that somebody put out for demonstration purposes. But and that's why when we look to the future with zero emissions aviation and other cleaner solutions, it's really difficult to beat a turbine on pure numbers, pure power to weight ratio, fantastic bits of kit. The typical mission of an islander, they tend to fall into two main categories. They tend to be commuter, so cram as much stuff in as you can and fly short hops, round robin around a group of islands, for example. That's the service operated in the Highlands and Islands in the UK and also in places like the Falkland Islands. So, a lifeblood, essential taxi service between remote communities. The second mission is really quite different, and it's interesting that one airframe can achieve them both, is an airborne survey, airborne surveillance, special missions type role, where instead of passengers and cargo, you're taking role equipment, so sensors, systems operators, that sort of thing. The reason the aircraft's good at that is because it can fly very slowly, and quite often it's hard to fly slowly in a fixed-wing airplane, and we do it very well. So a lot of those systems and sensors like flying slowly. Just because it's an old aircraft doesn't mean you're getting an old product when you buy a new one or when you buy a refurbished one. So this is our sort of gold standard, and if you order a new Islander tomorrow, they are available, then this is the sort of thing you'll see in the cockpit. So it's a far cry from huff and puff steam gauges that you would have seen in islands in museums. This is the Garmin G600 TXI suite. Lots of information available on it online for anybody who's interested, but for a very compact package, you achieve a fantastic level of capability. It's a mini airliner. It can do incredible things. So, yeah, this is not your grandfather's Islander, as the phrase goes. 29 by 29, the little logo up there. So the grand plan is to build 29 new Islanders in Bembridge by 2029. It's a challenge because that production has recently been reshored, so repatriated from Eastern Europe, and the aircraft were built there for a very long time. So bringing them back to the UK and making it a genuine UK product end-to-end, very challenging. But the will is there, the resources are there, and as you can see, these are photos taken recently. There is the nose assembly of an Islander being put together in the jigs. There's also, I'm going to move up, hurry up. This one here is the tail assembly. There's a fuselage there, and there's some controlled flying surfaces in the background there. So all the bits are coming together, and it will happen. Project overview. So that was the BN bit. It's now my pleasure to move on to the main event, which is talking about this program that we flight tested last year. So the problem, so it's always good to start with an exam question that you're trying to solve with special projects like this. So the wonderful level of connectivity we have and network centricity we have in things like disaster response and construction industries, fantastic. You're always in contact. There's 5G everywhere, great, except when it's not. And the bottom image there is from the recent floods in Portugal, which I think was this year. Absolutely horrendous flash flooding that knocked out a lot of the ground-based infrastructure. And that's not just mobile phone antennas getting knocked over. That's the power that feeds the mobile phone antennas. The people who go to work in the power stations can't get there because the infrastructure is all gone. So there is nothing on the ground level. And emergency services end up talking to everyone on walkie-talkies from Argos that don't have the range and don't have the capability. So wouldn't it be nice if there was a clever, rapidly deployable way of giving mobile data coverage to disaster areas, remote building sites, and other austere environments in which ground-based infrastructure isn't plausible? There is obviously a space-based solution, Mr. Musk and his Starlink and other such systems, very expensive, difficult to target in a very localized environment, and it's not a controllable asset that can be owned by a particular response team to achieve a mission. There will be lots of competition for it. So the solution that we worked on as part of this programme, it was a consortium of UK-based, largely UK-based companies. We were obviously providing the aircraft side of things, and I am absolutely not a telecoms engineer. So for that side of things, I urge you to go and have a look at the good people listed on here, stratospheric platforms. But the sort of my idiot's guide to it is, you want to achieve network coverage in a remote environment. To do that, you have a fibre optic cable coming out of the ground somewhere where you do have network coverage. You park a base station, like the van there, over the manhole cover that the fibre optic cable comes out of. Internets come up to that big dish. That dish talks to an aeroplane. The aeroplane has a wide area antenna that can transmit that signal and receive it back from assets on the ground, and then it can also relay back to the ground system. So you're essentially a Wi-Fi or a mobile data extender based in an aeroplane, which can be targeted at a specific area. Long term, this is potentially going to be marketed as a high endurance platform, so an unmanned, uncrewed system, potentially hydrogen electric fueled, solar powered, operating up there at 60,000 feet for a week on end. The world isn't there yet, so today's solution is based on the Islander, which is a good platform for it. So the mission. So aside from testing the equipment and doing the platform integration work, we also advised on how to take a telecoms product and make it work in an aerospace context. So part of that was designing the mission. So the ability to deploy worldwide at short notice and ferry that to wherever it's needed, to install the equipment in the field, okay, so potentially somewhere quite remote. The actual mission itself, take off, climb to a high altitude, stay there for a very long time, as long as possible, flying slowly. And 8 hours was what we were aiming for. I've put pseudo-geostationary there. Essentially what the telecoms people would like us to do is be a pole and not move at all. There's lots of different clever ways of achieving that, different racetrack patterns, different cruise climb options. So we talked through a lot of those and we'll sort of develop that with the product in the future. When running on vapor, fuel-wise, plus a little bit of reserve, descend and land. With a quick turnaround, quick crew change, and repeat. Bear in mind that could be a single or dual pilot operation, so potentially single pilot up there for 8 hours, flying slowly in circles, mildly unpleasant. So longer term, potentially an autonomy solution built into it as well, with initially the capability for a systems operator in the back. The reason this is important at this stage of the design is it tells us how many seats you need to have in the aircraft and what interfaces you need to have from each of those seats. And crucially, not a science project, not a one-off flight test article, something that can be flown all over the world, deployed and work day in, day out. So that's what we're aiming for. The certification strategy for that, and this is Mark Ship's world, our technical director, but to break down the big objective, the big design solution into manageable chunks. So the one that we're mainly talking about today is change number 1. I've hidden the titles for commercial reasons, but this is what's called a supplemental type certificate. That's just the way it gets approved. And that is a major modification as classified by the UK CAA. And that is to account for the aerodynamic effect of the great big thing stuck on the bottom of the aircraft. The other 2 changes install the equipment, so actually do the physical installation of that bulge, and the internals that deal with the telecom side of it inside the aircraft. So they were split out into 3 things. The main reason being the major one has a lot more engagement from the operator because it's a more serious change. So that's why they were split out. So, and I'm not expecting everyone to read this, Mum, but this is just to demonstrate, this is the drawing tree. So each of those boxes on there represents a drawing or a bit of technical detail that was developed by the design office in order to achieve the equipment being installed on board the aircraft. So it's not a one-off, quick duct tape it on to the bottom of the aircraft and go flying. although we did look at that, it just wouldn't work. This is a formal engineering solution that's been engineered properly. So here's what it started to look like. So it was a couple of slides ago, I put up the, this thing here. Have I got a pointer? No, that thing there. It's a very expensive, very sophisticated bit of telecoms equipment that I'm sure anyone from Stratford will be able to tell you more about. But it's fundamentally a lump that needs to be slung where it can see the ground, and it needs to be kept in a benign environment. So in terms of humidity, temperature, it needs to be in a controlled environment as well. So we needed to design something to contain that. And here's what we came up with, affectionately called the bathtub. So this is the bottom of the that's the floor of the aircraft in that one there, with a hole going down into the bathtub for the services and equipment to go into it. In terms of the shape, we started with the most simple volume that sort of interfaced nicely with existing infrastructure on the aircraft and that covered the expansion to the bigger antenna array that was envisaged. We did some subsequent aerodynamic analysis and basically concluded there wasn't much point in making it look pretty. You might see other aircraft, things like Beechcraft King Air, with a more rounded and sophisticated looking structure on the bottom. The main reasons for that are the higher speeds involved. With such a low speed aircraft, it didn't really need to be that pretty aerodynamically. At least that was the thinking. I'm going to present the findings of the flight test program shortly. So there's the bathtub. So that was a conceptual design. Just to give you a flavour of the sort of analysis that happens, so structural analysis was done, looking at it across the range of speeds and altitudes, and that's a visualisation of it bowing and deflecting with the change in speed. And that essentially proved that an attachment solution was built to keep the thing structurally attached to the aircraft well beyond its highest ever operating speed at sea level, the sort of worst case scenario. We also did some aerodynamic analysis. This is from a bit of software called Star CCM that looked at the aerodynamic, sort of virtual wind tunnel, computational fluid dynamics. So the things we were looking at were primarily drag, so the effect of drag of this large lump on the bottom of the aircraft. You can see it just behind the nose gear there, the wake modelled. And that predicted for us our reduction in OEI climb, one engine inoperative climb performance of 40 foot per minute. And that's the really critical thing performance-wise on an Islander. It's what happens when you lose one engine and whether it can keep climbing. So that's the main thing we focused on. So try and remember that number, 40 foot per minute, as we go through. The other fun thing was the predicted effect on stall speed. So typically, if you introduce a draggy item to an aircraft, you would expect that to have a detrimental effect on the stall speed, so the slowest speed at which the aircraft can fly without falling out the air. The modelling was actually telling us it would improve the stall speed by 1 knot. Various interesting reasons why that could be true. We thought we'd just follow it through to the flight test program and see. There's a saying in the design office that if Garnet's looking at drawings, then it's all gone wrong. So I won't linger on this too long because I'm absolutely not a mechanical engineer. But each of those boxes I flashed up earlier resulted in some very clever detailed design work. I believe this is part of the attachment solution for the bathtub. So yeah, lots of drawings that are initially done in CAD, 3D computer-aided design environments, and are then exported to traditional engineering drawings for production and installation. And eventually, this is what arrived. So, well, rather, an unfinished product arrived, and then we applied the finish to it. And this is the great big bathtub, the aerodynamic fairing at Leon Solent, ready to be installed. Another interesting fact about it was the only one in existence. So we really could not break it as part of this program under tight timescales. This is always good fun. So, having got our design solution, we've done our aerodynamics analysis and our structural analysis. We did a limited amount of performance and flying qualities analysis offline, so in our sort of desktop-based simulator. And this is fundamentally what it should look like. So aircraft accelerating along the runway, the unsolent, rotate, up and away, and you can see the fairing on the bottom there. So in theory, in the sim, all good, and that concluded tentatively that there was very little effect on performance and flying, well, sorry, on handling qualities. Okay, and then it was time to get real. So this is our flight test aircraft. Registration is Papa Oscar, GWBWPO. It's constructor number 4009, and this is a BN2T-4S Islander, so the bigger variant that I talked about earlier. And its career, it was built in 1997. It then spent some time in Malaysia, I think as a commuter aircraft, but someone can correct me, I'm sure, before returning home to be a UK military asset. And this was the in-country training aircraft for the UK MOD fleet. It's currently going through, at the time it was going through the refurbishment program, so the stuff I talked about earlier on being rebuilt, that's where this aircraft was at, and it was a convenient stage in that process to be used as a flight test asset. It's also handily in a clean, lightweight configuration because it never had a big mission equipment fit installed. It was always quite a clean, simple aircraft. So happy days as far as I was concerned. So what do we actually need to do as part of the flight test program? Where do you start? So the aircraft is certified in accordance with a thing called the type certificate, which lives on the CAA website, is held by us and is sort of owned by the CAA. That is a bit of paper that says, this is an Islander, you may go flying in it, you may fly above people's heads, and we don't think it will fall out of the sky. Contained on that document is the type certification basis. So this is a long list of things that it says this aircraft complies with. Included in there are things like, it is stable, it meets these kind of performance requirements, and various other relevant things to our modification. So we grab those relevant certification items, and they go into a certification program that's agreed by the UK CAA. We then, once that's agreed, put that into a certification program. We try our hardest to avoid flight testing anything whatsoever, because it's expensive and time consuming. But when there is really no other option, there's no other way to prove that the product is safe in this particular way, you stick it in the flight test plan. And that list you're left with at the end is what you actually go and flight test. It's not electrifyingly exciting, this process, but it is important. And interestingly, well, at least I find it interesting, it's the same process that Airbus and Boeing will go through to make big changes to their aeroplanes as well. So the fact that we, as a very small organisation, jumped through these hoops too, I'm quite proud of us for doing that. So that's that on a slightly smaller level. So our aircraft happens to be certified in accordance with this. Published in, it's the British Civil Airworthiness Requirements, which was published in 1974 and can be purchased for the price of £1. We then take that and put it into a BN document called the CERT program, and then put that into the flight test program. So everything we see from now on, the fun stuff, fell out of this document here, which links back to the type certificate. I flashed up an example here. So these are the handling qualities related test points. So you see the certification requirements are there. So that's things that are listed in that document from the CAA. What they are, what load we have to fly the aircraft at to make sure we get the worst case scenario, and then some other remarks there. So it resulted in 14 test points in total, 8 handling and 4 performance related, plus a couple with no associated cert requirements, but that would be useful data to gather along the way. That's things like mission profile development and other data that we needed for various reasons. Finally, these aren't just in any old order. We do things in a very cautious, progressive approach. So we check that the thing handles and behaves itself sensibly before pushing the envelope and expanding to more ambitious maneuvers. So the scene was getting there. All that paperwork was ticking along in the background. In the meantime, the flight test aircraft was being prepared. So I'm going to play this video. It might be the loudest thing ever, but we'll see. So off she goes. Thank you. So this is just the aircraft departing for, it'd been in storage for a long time, so it was de-preserved. It had its scheduled maintenance done, and it was sent off for an engine run and a compass swing, which is a procedure for checking the instruments on the aircraft are still aligned correctly with north as required. One of the joys of the Islander family is they're such simple aircraft that you can actually achieve an awful lot without flying the aircraft. You can get a lot of confidence that the aircraft will do what you want it to do without leaving the ground. So things like, will the engines spool up to full power? Do the brakes work? Do the flying controls all move as expected? All of that can be done on the ground without going flying. So that's what we did. Put this aircraft through its paces on the ground first. Other things we had to think about, safety management strategy. So I've briefly said, cautious and progressive approach, but actually there was a lot more to it than that, and that is dull, so we won't go into that today. But we had a full Part 21J compliant safety management structure in place, and a lot of effort was put in to get the aircraft clear of maintenance, so we didn't have to worry about any scheduled maintenance throughout the flight test program. Okay. This was something that caused us some worries as we got closer to the event. So it's a bit shadowy on here, but yeah, we were expecting it to be fairly close to the ground because we had all the drawings, but when you really see it in real life, it's really very close to the ground. And what I said earlier about being the only one in existence, and it's a composite structure, yeah, it was an interesting experience. But so there was a sort of pause moment to just go and check, okay, are the drawings correct? Are the oleos and undercarriage properly charged? Are the tyres inflated properly? Sensible things to make sure it was as expected. And as it happens, we didn't have any problems with it in the end. Whilst I was being a tour guide for the industry engagement event we held on the same day as the first flight, because I just hate my life so much. We were frantically getting the aircraft ready, and there's actually the legs sticking out from underneath it there are actually some of the reasonably senior people within the MRO at Britten-Norman. So it was all hands to the pump to get the aircraft into good shape. And that lump that they're installing on the bottom is the array that then gets covered by the fairing for flight test purposes. So we did actually fly with that very expensive, unique bit of kit installed on board the aircraft as well. It was also more than 30 degrees on the day of the first flight, which always adds to the fun with your 2 fireproof layers on for the day. But ultimately, the aircraft was ready for its first flight, so let's go. So this is lined up on the runway. It's GT's hands. Final check of the engine instruments. Turn and burn. Worth noting that this does not have a nice shiny Garmin cockpit like some of the other aircraft that I showed in the promotional images. Quite handy in a way, because this sort of semi-refurbished aircraft gave us the opportunity to just have what we needed, which was basic flight instruments. We're certainly not doing anything bad weather flight test-wise. We don't fly in bad weather. And just to install a couple of bits of Garmin kit, the 2 GTN 650s. Very inexpensive, very effective little navigation and communications kit. So that was us getting ready to go. And here we are. It's obviously not fully professional quality videos, I'm afraid, but we did get some good photos out of it. So this is Leon Solent's near Portsmouth, in South England, which is our final assembly facility and also where the MRO is based. And off she goes. It doesn't look real, does it? It looks like a model, but I assure you it did happen. I was there. So we went off, and then about 40 minutes later, we came back. So flaps down, nice and gentle, clenching somewhat for the ground clearance on landing, but down safely. So there we are. We went and we came back. What did we achieve? So we did a shakedown flight to make sure nothing fell off, and we had actually had some last minute challenges with that. So during that installation, for example, a thread stripped on the bolts that hold the fairing to the bottom of the aircraft. So that was doing the right thing, not just pushing it loosely into there and hoping it'd be all right. Stop, back to the design office, stress analysis re-engaged with that thread missing. Does it still achieve the desired safety margins? Yes, let's go flying. So we did that shakedown flight to prove its mechanical and structural integrity, and also just the feel of the aircraft as a almost informal performance and handling qualities assessment. So we proved that it could take off, conduct its initial climb. We did depart the circuit and do some stalls just to prove these sort of really critical flight safety parameters, and check that you could trim and fly safely with the flaps down. So this meant we had a known envelope, so a range of speeds, heights, and flap conditions that we knew were safe. So if we discovered anything untoward later in the program, we knew we could revert to that safe envelope and get safely back to Leon Solent. We also had our customers and industry partners on site, so we did a brief fly past to show off the aircraft in that configuration, which was actually really good fun and it worked very well. So initial findings satisfactory. We then moved on to latter stages of the flight test program, so envelope expansion. And this is an example of a test card. So, well, BN calls them flight test instructions, but this is the A4 bit of paper that I have on my leg, on my knee board, when we go flying. So this one in particular is for minimum control airspeed. Got my aeroplane on a stick out. So again, there's probably people who can define it much more concisely than I can, but fundamentally in a twin-engined aeroplane, if you're flying along very happily at max power with both engines, if you have a sudden engine failure on one side, it becomes a tug of war between the functioning engine and the rudder and the fin. So the engine wants to spin you thus and make you lose control. The rudder's trying to stop that from happening. The rudder works better at higher speeds, so as you get slower and slower and slower, the engine starts to win. And there is a critical speed, the minimum control airspeed, VMCA, at which the rudder cannot sustain controlled flight. It's the red line on the airspeed indicator on a multi-engined aircraft. It's quite important, this one. And in many aircraft, before you hit that minimum control airspeed, the point at which you can't sustain safe flight with an engine failure, many aircraft in our class will stall first. Okay, you're going so slowly, it just falls out of the sky, so this is irrelevant. Because the Islander flies so slowly and so superbly at slow speeds, you can encounter VMCA, minimum control airspeed, so a really important parameter. Why were we worried about it? Well, worried about it. Why did we think we needed to prove it for certification processes? The fairing, I did have some blue tack on here a while ago that showed it, but bear with me, is in front of the aerodynamic center. So when you have an engine failure, you have a bit of twist, a bit of side slip angle, the wind has something to hit, and it could potentially contribute to the tug of war against the rudder and make that situation worse. A lot of the text on that card talks through the way we iterate down towards it. So we do it progressively, we target the speed way above what we think the minimum control airspeed will be. We gently shut down an engine first before we go to slam it shut at slow speed and see what happens. So very cautious. We also conducted, we ballasted the aircraft to achieve either its heaviest weight with its furthest forward central of gravity, CG, or a lightweight aft CG. Those tend to be the two worst case scenarios. Generally, heavyweight forward is bad for performance, and lightweight aft is bad for handling qualities, with some exceptions. So I've talked about minimum speed airspeed. We also did dynamic stability, and the plan was to dive to the design dive speed of the aeroplane, which in an Islander is about 208 knots. That's high speed for us, and there's probably people in the room who don't consider that to be high speed. I certainly have flown in faster airplanes, but it can feel exciting at the time. So noteworthy findings from this handling qualities evaluation. There was an interesting characteristic on takeoff from the lightweight aft configuration, whereby the aircraft was fairly keen to fly by itself with not that much pilot intervention. So it wasn't particularly repeatable, and It didn't occur at all load configurations, so a slight unknown. Fortunately, once you were off the ground at a sensible speed, there was no continued tendency to nose up. It just responded as normal. So the working assumption is it's an interaction between the runway surface and that downward sloping area on the front of the fairing, and it's essentially pushing the air down, which is pushing nose up. On the whole, though, you could forget that you had the fairing installed, which, considering how big it is, was quite a pleasant surprise. Directional axis response. I've put the words mild Dutch roll type characteristics and localized directional sharpness. So obviously, Dutch roll, for those of you that have heard of it before, can be quite an alarming term because there was challenges in the industry in the 1950s and that sort of era of airliners breaking up mid-flight because of Dutch roll. Dutch roll, really simply, and apologies for those of you who already know, is an interaction between the yaw axis and the roll axis. So if a wing, for any reason, accelerates, it produces a bit more lift. It then has a bit more drag, so it decelerates. That accelerates the other one, up she goes, and you end up lazily rolling your wingtip like this. So that was interesting, and we weren't necessarily expecting it. And I've got a little video of it here. So what we're seeing here, this is the wingtip. When I play it, we look at the wingtip tracing its oval in the sky, and then you will see panning into GT's hand, pressing a button in the cockpit, and then we'll see what happens. So there's that lazy oval, press a button, back out, and it stopped. So that button is the yaw damper, which is a function of the autopilots that just puts in very small little rudder inputs to counteract what it sees to be a side slip angle. The autopilot on this particular aircraft is not particularly state-of-the-art. It's got a simple bit of kit, robust and simple. The fact that that could cancel out that little bit of Dutch roll was quite a reassuring fact. That quite a simple bit of kit was able to counteract it, eliminate it completely, was reassuring. Crucially as well, this only really occurred at speeds beyond the envisaged roll of the aircraft, the envisaged mission of the aircraft, and if you did basically anything in terms of speeding up or slowing down, it went away. So an interesting flight test finding, but not of any great consequence for the finished product, which is really pleasing. I'll do it one more time because I like it. So lazy oval. Just, no concerns other than it could be potentially quite uncomfortable in a long mission doing that. Yaw damper engaged, Dutch roll eliminated. Beautiful. So that was the handling quality assessment. As I said, fundamentally, not much effect, which is what we want. Performance-wise, the thing we really focused on here was the single engine climb performance, as mentioned before, OBI, and the stall performance at all flap settings. This is talking about the OEI climb, so looking out the window at the left engine, and in a flight test scenario, this is all very routine and undramatic. I would be perturbed if I saw this whilst off on my holidays on BMI, but in an Islander, engines are close into the fuselage. This was at a sensible power setting. It's a bit of a non-event, almost, the engine, an engine being deliberately shut down in flight. So we did that, we shut down an engine, and we flew around perfectly happily south of the Isle of Wight for a couple of hours doing climbs. I'll do the climb forward first. The simulation predicted we'd get a 40 foot per minute decrement to single engine climb, and what we actually ended up with for single engine climb was minus 29 foot per minute. So we were slightly better than the simulation, which was pleasing. Interestingly, for climb with both engines operating, we ended up with a plus 13 foot per minute increase in twin engine climb performance. I am tempted to say that was an experimental variability / engines being run in / within the normal tolerance of business, because you see the rate of climb is potentially up to 1600 foot per minute in that scenario, so plus or minus 13 isn't that big a deal. So the official position out of this was no effect on twin engine climb and a small modest decrement on single engine climb. Back to that stall, and where the simulation predicted it would make the world better, we couldn't detect any effect. So no decrement, which is pleasing anyway. So to wrap up, we completed the program successfully, which was 5 flights, but really quite long ones, well, for us anyway. So 8 hours 40 airborne, all flown by GT and myself, plus we had some cameo appearance from one of our design office interns who's since gone off to join the RAF. But it was pleasing to get young people involved in the program. We had no safety concerns throughout the flight test campaign, which is always very important for us. And yeah, those 3 characteristics that we identified that we thought for the certified product would be prudent to include in the document you get with it when you buy it. So due to that lateral axis response that I talked about with the Dutch roll, we did bring the maximum operating speed back a bit. But bear in mind, the objective of this product is to fly at probably 90 knots up at 25,000 feet, basically as slowly as economically practical. The limit we put on it was 151 knots. So really, apart from in an emergency descent, 0 impact on the roll of the aircraft. And that was out of abundance of caution. That slight reduction in single engine climb performance that needs to be factored in for flight planning purposes, weight and balance purposes. And that note about potential nose lightness on takeoff. I won't linger on the certification bit too long because it's not very interesting, but it is important. So how do we get from scribbles on my test cards, flight test data, to a certified product? So GT and I publish post-flight reports, which are our raw data that then get distilled into a very presentable and professional flight test report that forms a formal part of the certification process. We recommend content for the aircraft flight manual supplement, the operator's guide, and that includes formal limitations for things you must do or must not do when you're flying the aircraft with this installed. The CAA, we then present that to the authority in a compliance record, against which a certificate of design is issued to say this is a product that is certified to fly over people's heads in the UK. And the SDC is issued. That's the summary of what the flight test report says. So, as my anybody who works for me, people who work for me in the room know that I enjoy a table with a green background to show that everything's okay. So this was each of the test points that we wanted to test, the certification requirement that we were satisfying, the configuration that we were flying it in, and a statement saying why that is okay and acceptable in our case. And that's a little excerpt from the flight manual supplement. So this is, as a pilot, what you'll get if you buy the product and you fly the aircraft to this. Essentially, a limitation as discussed saying the speed is limited to 151 knots. Some notes that might be useful for piloting strategy and awareness, and some performance figures that come from that single engine climb decrement. That's the supplement as it looks. So an addition to the flight manual of the aircraft if you have this thing installed. And that's the prize at the end, a document issued by the UK CAA, which is the supplemental type certificate. So this is our one, and you can see the title at the bottom there, aerodynamic defect of large externally mounted equipment on the aircraft belly. Worth pointing out, this wasn't actually tied specifically to this program. So this, an object of that shape and size is available to install on all BN2T-4S aircraft now for whatever reason it might be required in the future. Okay, it's time to wrap up. So as discussed, from a technical perspective, it was a positive outcome because we satisfied all the cert requirements and achieved a major design change, which, as discussed, is the same process that huge multinational aviation organisations go through. I mean, there's probably more people in the catering department for those programmes than there are in the whole of Britten-Norman, yet we still achieved it, which is quite a satisfying thing to do. The real-world data correlated pretty well with the simulated outcomes, and you know, our simulation facilities are simple, basic, and appropriate for the type of aircraft. It's very conventionally configured aircraft, low speed, low altitude, it's quite satisfying that we can take those products and get real meaningful data out of them. And yeah, the important thing, and I think that you get drilled into at the Empire Test Pilot School, is that the solution is not just safe, but also fit for its role. You could happily fly this around at 25,000 feet slowly for 8 hours if you really wanted to. So that was the sort of technical outcome. From a personal level, some things that were quite satisfying. It was actually a proper flight test. A lot of my flight test activity in career previously had been what I'd term verification activities. So things where you really knew what was going to happen, you just had to prove that it really would happen in reality. Whereas this was a totally unknown configuration of aircraft with this new aerodynamic configuration on the bottom that nobody had ever flown before in that configuration. That was quite satisfying. I know GT probably wasn't as excited as I was, but yeah. And it was a big aerodynamic change. So people can be quite blasé about the Islander and installing equipment onto the outside of it because it's such a tolerant, robust airframe. There's a sort of, oh, it doesn't matter, it won't have any effect. But this thing was enormous. And it was good to challenge the platform and to prove that there is actually a point where you do start having an effect on it. I think we were just perfectly on that boundary with this product. And yeah, there was enough interesting technical content in the flight test program to make it engaging and make it interesting and fun, but without anything that required a big redesign or anything else that would have caused it to be commercially unsuccessful. And the program touched every part of BN. We designed and manufactured, installed, and flew this bit of kit, which is quite satisfying. Worth mentioning as well, the aircraft, the baseline aircraft without the antenna on it, we flew that for comparative purposes. It's an aircraft that had been in storage for, I think it'd been 4 years, and it performed absolutely flawlessly. It was, I think GT's words were silky smooth, at least by Islander standards. So that was really satisfying that an aircraft built, well built in the first place and well maintained during the flight test program, and a successful collaboration between some smaller UK-based companies. And yes, we had some involvement from young professionals. I distinctly remember when I was a little bit younger in my flight test career, there tended to be two categories of older flight test engineers. There'd be the ones that would help you and the ones that with the Velcro flying suits, who would be very keen on doing all the flying themselves and not talking to anyone. Obviously, I want to be the one that helps people get into the aircraft and helps people get into flight tests. So we had some of our design office interns helped out with the ground runs, and one of them was able to come on one of the flight test sorties with us, with a valid role on the aircraft, not a ballast or passenger. And yeah, a full end-to-end participation in the program. So some of those awful looking documents that I put up on the screen, I wrote a lot of those. So it was quite satisfying to go from initial scoping, me personally, of the program to say, hey, do we think this idea might work, to hundreds of pages of certification documents, to sitting in it on the runway, lined up, ready to go. It was really quite satisfying. I think that's really what I get out of bed for in the mornings, that end-to-end participation in the flight test program. Okay, I've got a few minutes just to talk briefly about looking ahead. So I'll split it up into some sections. So firstly, what's next for that aircraft? So the aircraft was de-rolled and put back into the refurbishment program, and it will be on the market shortly. Again, if anyone's interested, let us know. There's a lot of interest in it, actually, and I'm sure it will go and have a new life somewhere. I'll be sad to see it go, but it's a fine aircraft, and it will do somebody a good service. And those are some images of, it's not actually that aircraft, but it's one of its sister aircraft from a few weeks ago at Lyon Solent being rebuilt. I think that particular one is going to a customer in Guyana, which is, it's going to see a lot of service out there, so very satisfying. The program itself, so the project stratumast, stratospheric calibration. So the project won the prestigious award from the engineer. So it was the information, data, and connectivity winner for 2024. It's an award-winning program that is pursuing lots of different opportunities for deploying it in different scenarios, so disaster zones, construction sites, lots of other ones as well. Important to note as well, we didn't just build a one-off that would only fit on 4009 flight test aircraft. It was designed to be role changeable for other BN2T-4S aircraft, so it can potentially be installed on any of those in the future as required. And finally, Britten-Norman. So, yeah, we're a modern British aerospace engineering small medium enterprise company. I have to put the comma in there to make it clear we are not British Aerospace. There's a significant focus on new build production at the moment. I said my 29 by 29, so that is the primary focus of the company at the moment. We are also sustaining our special products capability to run similar programs in the future, because that's really exciting bit of work and a good use of the expertise within the company. Because the aircraft's been in service such a long time, there's some challenges with obsolescence. So, you know, the aircraft was born into an ecosystem where there was a huge aerospace industry in the south of England of people building aircraft from scratch, where you could choose whatever you wanted from a catalogue and it would arrive on a lost-in van the next day. We don't live in that industry anymore. We're a bit of an outlier, really. So sourcing key components to keep the aircraft flying cost effectively is a huge challenge, but that's one of the things we're spending a lot of time on. But we're not forgetting to improve the product. So I've already showed the Garmin cockpit, the glass cockpit solution for the aircraft. Lots of other product improvements coming on, and that's a whole nother presentation in itself, so I won't go into that today. And even further beyond that, as an environmentally conscious company who wants to remain relevant in the future, we know that we need a reduced emissions solution, ideally a zero emissions solution, not just for the aircraft, but for the whole organization and all the activities that we undertake, including powering the production lines, some of those really energy intensive processes. The forecasting, so if you follow the logic of 29 by 29, plus some special projects, plus the work the MRO is doing refurbishing aircraft, plus some customer demonstration flights, plus, you end up with over 80 flights per year, split between Bembridge and Lyon-le-Solent. So that's really significant and exciting to be part of as a flight test professional. I wanted to finish, I've mentioned that we are recruiting and sort of, expanding's the wrong word, we are resourcing ourselves to do what we should be doing. And as part of that journey, we had some investments last year from Tim, who's in the room. You can talk to him after if you'd like. So when Tim introduced himself to a Tool staff at the quite a fraught time when we'd been focusing on raising that investment and there'd been a little bit of uncertainty, Tim said, I'm here, I believe in BN, and I want it to be a place where you'll want to work and you want your sons and daughters to work here too. And I think that's a really nice message, and that's how I feel about BN as well. So for anybody, young professionals, old professionals, anybody watching on the YouTube thing, if you're interested in part of that journey with us, the details are all there, so please get in touch. I hope that's been of interest, and I'm very happy to take questions if we have time for them. Thank you. Yeah, I don't have to listen to you anymore. That's the difference.
Hiya. Sorry, about the electronics rather than the plane, I'm afraid. Are you doing any more work with stratospheric platforms, or is that it done and you're now onto other things?
I think we would love to. I don't know what's planned at the moment currently, but keep your eyes out for updates.
Balls in their court. Okay, yeah. Thanks.
That was easy.
Thanks a lot for a great presentation, very insightful. Two questions. Do you compete with your platform against other platforms in order to get the contract to begin with? And what did the business case look like in order to secure that investment? Was it on the basis of LOIs or ideally firm orders?
Yeah, so I can't speak too much to the commercial side of it. Charlie, who sat a few rows back, will probably be able to tell you stuff afterwards. But in terms of the other platforms, I believe we were the only conventional fixed-wing aircraft in that program. Some of the others were unmanned, uncrewed platforms. There was even, I believe, a lighter-than-air solution, a blimp. That's probably the wrong technical terms. I don't like lighter-than-air aviation because I'm a fixed-wing person. But, there was some other more novel platforms, and I believe that the fact we were a proven platform that has already got a track record of flying with mission kit on board really worked in our favour. So I think that was advantageous. In terms of the investment and stuff, we weren't the consortium lead. The consortium was led by SPL, Stratospheric.
Okay.
So that side of things was generally looked after by them. We were a consortium partner.
So that's where the funding came from to support the development and the testing?
Yeah. Okay.
Thanks.
Thank you.
Nigel Franklin. I'm curious to know the basis on which Stratospheric want to go forward, what they're planning to do now. They've got this this design certificated so that they can use it. What's the business model? Are they going to be... the nature of the use is unforecast usually. It's that disasters happen and you have to get something happening pretty quick. So what's the plan that they...
So obviously the obvious caveat to this being I am Britten-Norman and we were a sort of subordinate partner in that.
Yeah.
But I think to my personal view of it, the business case would be disaster relief type organisations that coordinate the emergency response to a serious emergency condition worldwide would provide that, would be the owner of the product who would then deploy it, or the owner of the service rather, who would deploy it in that way. But that's...
Okay. And the subsidiary question is, when is the first all Bembridge built aeroplane coming off the line?
There will be 29 aircraft by 2029. And I believe, bear in mind, the CEO of Britten-Norman is sat 2 seats to your left, so he might have a different view, but all going well, it should be this year.
Yeah, okay. December, very good. Excellent.
Hi, I was wondering, for the design of the bathtub, is that meant to be a modular design, or is that going to be a permanent fixture to the aircraft?
Yeah, so it's so when you buy it, you get the STC, so you get the certificate to say it's safe. You get a whole suite of other documents. One of them is the modification instruction, which is like an Airfix type kit. It tells you here are the parts you need, here is how you install them, and the last section of that is how do you remove it again at the end. So it is a installable and removable configuration. Obviously, all mods are different. This one pretty easily, because part of the envisaged use was flying it overseas, ferrying it long distances. You don't want the kit on the outside of the aircraft for long ferries across different countries, because it looks a bit conspicuous. You might get questions from armed officials in various places what you're flying. It's not good for the kit to be on the aircraft when it doesn't need to be. A whole host of different reasons why it's advantageous to have it removable. So, and in fact, one of the photos, that was the aircraft being jacked up so they could install the kit after it had done the aircraft done its ground run. So yes, roll reconfigurable is the idea. Yep.
You mentioned some interesting reasons for why it actually increased the stall speed slightly. Can you elaborate?
What a great question. I've got the serious one, got the aeroplane out. When you're stalling, when you're in that pre-stall condition, you're fighting to keep the nose of the aircraft up. The nose of the aircraft wants to go down because it's not producing enough lift. You're introducing a surface that points downwards a bit like a flap on an aircraft. So that, backed up by a bit of CFD, gives you a small nose up moment, which could be contributing to help the elevator out a bit to prevent the nose coming down. It could also be just an increased surface area, just producing lift in that particular configuration. Or it could be a completely spurious result and it has no effect at all. This is the joy of flight test, and this, worth noting that the data that we get from this is generally me looking at the instruments and writing stuff down. We're not a networked, instrumented aircraft because it's not proportional for the task.
A second question, if I may. You said that you properly refurbish craft, unlike some other companies? Could you sort of compare and contrast? What are you doing differently?
We do the most comprehensive factory refurbishment. In fact, the only OEM factory refurbishment program for Islander aircraft. With the type certificate holder, got all the UK CEA approvals to do that to the aircraft. You can't get better.
Thank you. You said about you did 5 flights with over 8 hours. So just clarify, was that 5 flights totaling 8 hours, or?
Yes.
Right. Okay. Wasn't one each.
Yes. So part of the challenge is, if you're doing your single engine climbs, you need to be heavy and at a forward CG. The longer you fly for, the more fuel you burn off and the lighter you become. So you can't just do it all in one long flight, because you end up being off condition weight and balance wise. So you have to land and take on fuel.
And another, if I may, you say about how you're looking to keep improving the Islander. Would there come a point where you'd have to actually design a new type of aircraft going forward?
That is a very, very difficult question. I would say, if you look at other aircraft that are available who have tried to design a new or a modern Islander, I'm just going to say it, Tecnam, the P2012 Traveller, essentially they're targeting the same market as us with a more modern design. And if you go and look at their website, there's lots of great material about how they're not naming any names, but the traditional British STOL aircraft is inferior. But a new aircraft has to comply with the newest certification requirements. Our aircraft, the type certification standard, is a lot older, and it's got a big pedigree and heritage behind it to prove it's safe, compliant with those conditions. So newer aircraft, it will be bigger, heavier, more complicated, and I would posit loses the character of the simple, robust aircraft for that role. So I can't see us developing a from-scratch model alternative anytime soon, because it's very expensive and it wouldn't be as good.
Okay,
that's just me reckoning, though. I don't know if it's true. Thank you.
So just to follow on from the stall performance question, did you investigate stall characteristics at all?
Yeah, so there's certification requirements associated with the stall speed. So they're actually confusingly separated out into, hugely separated in the document, stall speeds, 50 pages later, stall characteristics. But it all boils down to there's a height loss requirement, there's a roll angle, maximum angle of bank requirements. Yeah, all that stuff is there. So I focused on the speeds there because it's the easiest thing to flash up on the slide. But yeah, it was a stall performance and handling. And sadly, it's very boring in an Islander. Stall speeds, talking 40-ish knots, nothing really happens. It just gives up and then you recover. That's it.
Did you have to consider icing at all in your flight testing?
Again, an excellent question. So the baseline aircraft is equipped with flying system known icing mods. So it's obviously an all-weather aircraft in its previous life as a military aircraft. The role of this aircraft, with the mod installed, it was just a step too far, I think, to consider icing, because it's a very specialist area. You have to look at the ice accretion on the front of the structure. There's lots of other things that get quite complicated. So it was a no flight into known icing conditions is sort of implied in the mod. So not currently.
I was just wondering about consideration of operating off of unpaved strips, grass, given the clearance issues, maybe.
Yeah. It gave me nightmares at the time. But one thing to bear in mind is we were investigating it and making it deliberately worst case. So we were loading the aircraft up. We were putting the CG as far back over those back legs as we could. And I think in a more realistic, a more typical load configuration, to have a bit more clearance. But we haven't tried it yet.
Thank you. Out of the 7 aircraft you hopefully want to produce over the next year, your first airframe, I'm assuming, is brand new and not regurgitated. Have you actually got a customer for that aircraft?
Yes.
Oh, that was a very quick answer. Thank you very much.
Because it is the truth, yes. Yeah,
well, that's very good to hear.
Yeah, there's some statistics available somewhere, but the first aircraft is absolutely contracted with a customer, and there's a production waterfall with the little asterisks next to them for aircraft that are spoken for. So there's aircraft available, and there are some that are earmarked.
Thank you.
Thank you.
Don't worry, Garnet, I'm not going to ask a question.
Yeah.
I'm just looking at the... all the questions are done. So I'll just bring proceedings to a close. So 2 things to do. Thank you all for coming and for your questions. And thank you, Garnet. Dr. Ridgway, it's been absolutely lovely to see you. It's been too long. So let's just give him one last round of applause.